So here, continuing with the same thing, we're going to talk about the closed loop automation of software issues. The previous example was caused by some hardware problems, and this is a software problem. So again, the digital twin is critical. That's our starting point. After the successful installation, digital twin gets created. And here, the same dynamic thresholding capabilities that we talked about in the previous demo, they come into action by the cognitive decisions capability. And then in this case, they are continuously checking for some memory CPU errors. Here, they found out in this example, they found out an excessive memory errors in one of our access points. And this happens due to a variety of reasons. It could be that, it could be a runaway software process. It could be many reasons. But the cognitive decisions capability, they continuously analyze the data, and then they have detected that there is a problem here. Now, while doing that, they just don't simply stop. They immediately raise an alert, and that alert is reflected in the Nile autopilot, that application that we saw. And then there's another magic that happens. They automatically look for any existing software issues with the similar signatures. And this is where all the AI magic happens. They look at our Jira database. They look at all the different issues that we have seen across the other customers. Has anyone else seen this problem? Does the signature matches that problem? Now, once they see that, if there is an existing Jira ticket, they immediately cognitive decisions, they analyze it, they associate that ticket with that alert. So once that's done, they auto-correct the situation, either by rebooting an access point or redirecting the traffic through other links. All that auto-correction happens, and immediately they send an alert to the customers. The first customer success manager, hey, there is a runaway access point. We found out that there's a software problem in this case, and for whatever reason, your access point is not running the latest version. You may need to schedule an upgrade, right? Immediately, this also happens automatically. And then after that, cognitive decisions also, if possible, the customer has a maintenance window set, it creates a maintenance window for that software upgrade in that particular period of time where the customer has set the window, that allowed a window for us. And then once that is done, once the software is successfully upgraded, now the digital twin gets automatically updated with the latest information, latest software. And then someone asked the question about with the dynamic threshold and detect. Yes, it will again go back to detecting, to making sure that the memory errors are no longer happening. So this is how it closes the complete loop. Again, here also, like in the previous example, there is zero interruption to the network. Users are not aware of it. IT administrators are not aware of it. The only thing they come to know is actually there is a problem in the AP and we need to schedule a software update. That's the closed loop automation. Yeah, here is an example. This happened in one of our customers. And here there is instead of memory error, we found an interface discard error. There's a sudden spike. And here's a ticket that got created. It happened in an AP. It happened in this particular site. The condition got cleared after all that update happened and then got closed. But let's talk about how what happened here. So here is the digital twin. We start with that. And in this particular case, there's this AP was the one that is experiencing the software problem. And the software problem is interface and discard errors. And all that auto analysis happens here. And once that auto analysis happens, it looks for a particular signature here, a software issue, AP model 1050 known issue, have interface discards. And here's the magic. This is associated with software 57425, an existing software problem. Okay. And sorry? Yeah, Jira ticket. This is actually a Jira ticket that our engineering team already worked on or working on. So once the ticket is attached to this, and once that software is upgraded, now the digital twin, the cognitive decision modules, all that happens in the background. The analysis, they look at this data in the interface data that we collect here. Yeah. So here, all these interface data that we collected here, interfaces minute. So this will tell us what happened in the TX error. Did that come back to the normal state? So once the cognitive decisions have determined that this has come back to the normal state, the ticket is closed. So there is that software upgrade portion, the one that we need to schedule to the customer. That is the only manual part, that too from the customer side. Once they do it, that upgrade process, I think, is going to be the next demo that Dipen is going to show, how even that is completely automated and closed loop manner. Any questions?
And just to clarify, this view that you're showing us here, is this what we would be able to see in the ticket, or is this the internal?
This is the Nile autopilot. This is internal to us. This is the one that our production network engineers use. Okay. And most of the occasions, these tickets, they get auto-closed. They get raised, and things, either auto resolution happens in that previous occasion, link, redirects happen, OSP, of course, all that happens, and then they get auto-closed. Or in some cases, like in this case, it may be open for some time because there's a work order associated with it. But it's used by production network engineers.
In this scenario, we essentially saw infrastructure not impacting any quality, any service, but we detected that, hey, there's something off from the baseline of the hardware that's installed in the block. Again, Nile Services Block is like infrastructure as a service. Similar to the cloud, we might be still watching videos and the Netflix service is up and running, but you know what? We're seeing deviations. Memory usage is spiking, interface error rates are spiking. We should do something about it before users start complaining. So we created a ticket, we notified the customer. The good news here is our data model now has incorporated the Jira tickets from other customers, of course, not the personal information of those customers. And we start looking for issues that we have seen in the past from other customers and whether we have a resolution of that or not. Traditionally, if a customer runs into a software bug in a network, what happens is they raise a ticket. First of all, eventually users, then the network will get impacted for them to notice that there might be something going on with the software. A bunch of troubleshooting happens. Device logs are collected and emailed. Support ticket is created. And we start troubleshooting. Tier 3 says we need to take a look at the crash dump, if there's a software crash, and the log files, and then bring some engineering team, and they manually look at their Jira ticket database and say, you know what, that, the fifth one on the list in the Jira ticket is actually, might be associated with this. They schedule a maintenance call to do a software upgrade. Today's enterprise networks at the edge, campus and branch, they utilize monolithic software architectures. You upgrade boxes. They're not microservices based traditionally. If I'm upgrading a controller-based WLAN, I'm upgrading the controller, it upgrades all the APs, and I have a new software release. Those software releases usually get baked in and shipped every 5 to 6 months. They come in not with a single fix, they come in 50 others with 10 pages of release notes. We have all seen those. In our case, only this specific fix gets pushed out to the microservices at the edge. And the good news is we don't have many different releases anyway, so the customer is probably very close to the final release if we need to do a full hardware upgrade, full network upgrade for any one of these issues. So that brings us to the last demo. When the time comes for a maintenance window, full system upgrade, or microservices update, how do we do that? How do we run automation for that scenario? Dipen, back to you.
So now a customer needs a software upgrade, and there are two kinds. One, Ozer already alluded to, like a fix cannot wait. So the hot fix has to go right away. And that's where our microservices-based architecture at the edge helps. If I can upgrade just that one process that needs fixing, I can do that, get in, get out, done for the day, right? But for the larger software upgrades, we get something called a recurring maintenance window from the customers. And once those recurring maintenance windows are agreed upon, our production network engineering team will schedule a maintenance operation for software upgrade. And again, going back to our closed loop principles, we need to make sure that the health of the software upgrade itself is A-OK, which means I need to leave the customer's network on par or better, right? So that's where we do a lot of things differently. Again, going back to the service mindset, What we had to make sure is, what does the network look like before? So again, going back to the digital twin, what does the digital twin snapshot look like just before the upgrade? And we check for several different things in there. There's like 20 different metrics from inside out, which is from the core itself, and then from the outside in, meaning what are the type of devices connected, how many, what time, and so on and so forth. Once that snapshot is taken, then the upgrade is automatically performed during the scheduled maintenance. Mind you, the P&E team or the production network engineering team is not really online watching, looking at a dashboard with some progress bars. They're essentially offline. The upgrade has triggered. Once the upgrade is done, a post snapshot is taken. And once the post snapshot is taken, now you have exactly the copy of what did my digital twin look like before and after. And we're talking about the environment's digital twin, not just per element. And if you spot some very gross discrepancies in those, that's going to trigger an automated alert to the P&E team and say, hey, Mr. Production Engineer, you got to take a look at this. I found some post NSB upgrade discrepancies, what needs to be fixed, and so on and so forth. Okay. So with that said, I'm going to jump into a quick demo. Okay. So in order to save us some time, what you're looking at on the screen here is essentially a snapshot comparison of a pre and a post. And as you can see, there are several parameters we check for: device lists and statuses, outstanding software upgrade failed alerts, are there any settings that were rejected, device unavailable, LLDP. There are so many metrics. The one that I specifically want to bring your attention to is something called the long-term clients. What does that mean? This is where, again, our approach of not just inside out, but outside in comes to play a role. We have to look at things 360 degrees. Why did these devices not connect back? The upgrade was performed after hours. These devices were like these loyal devices, kind of stationary in nature, maybe some IoT sensors, maybe printers, always connect back. They were there before the upgrade. Why did they not connect back after the upgrade? I don't want my customer to panic when they walk in next morning and find these devices offline. So an alert would have gotten triggered to the P&E team, the production network engineering team, and they would have been able to wake these devices up. Most likely these were silent type of devices that essentially are not that chirpy, or they just tend to like remain silent. And we all know what silent devices do. So we are able to catch that, close the loop on fixing it before the customer walks in the next morning. And that's essentially what we do with our software upgrades with, again, a service mindset and closed loop automation in mind.
All right, thanks, Dipen. So that was the last demo. I have one more slide, but just to highlight maybe what Dipen already shared, the upgrade process happened within the entire service block or set of service blocks for the customer site. We treat that service block infrastructure as a service, switches, APs, sensors, everything else running a single software release. We do this back and forth comparison. Traditionally, you will compare your maybe show running config on a switch before and after the upgrade to see if everything is in order. But this time we're collecting everything around the core, the context, and the environment, since we have a copy of it in the digital twin. So what's so different about Nile? We figured we highlight what's so different. We're trying to redefine some of the status quo, maybe move past some of the traditional ways of operating an infrastructure, designing, deploying from day minus n to day n. We want to establish the as a service model at the edge, similar to how the cloud model has grown. Some of those principles impact our budget flexibility. Some of those principles impact our speed of rollouts. And there's other capabilities that the operators of these networks, experts that are going to run these networks, they're going to be responsible for the outcome. We said, hey, we have to share the responsibility of those outcomes with guaranteed coverage, capacity, availability metrics that we provide. And to help us scale as a company so that we don't hire 10,000 people to support 10,000 networks, we had to rely on automation to predict what could go wrong, automate manual tasks in software, utilize AI when we need to after we convert a lot of the knowledge within this infrastructure into data. And that integrated data model is really the secret ingredient in what we can do. Without that data model, without that automation, we cannot deliver a guaranteed service. We cannot convert the edge infrastructure to infrastructure as a service. And we cannot really enable this closed loop automation piece. So that's really what's so different about Nile. Hopefully that came across through that talk track and the demos.